Lesson 3.3, Slope and Rate of Change. The slope of an equation is the steepness or slant of a line. This is also the rate of change in the equation. And the rate of change can be found as the dependent variable divided by the independent variable if we have a direct variation. So this is in a direct variation. So we get y over x. So when we had the direct variation equation, we had an equation of the form y is equal to k over x. So k was the rate of change, or the slope, and k can be solved by dividing y by x. There are other ways to find the rate of change for an equation. We get the vertical change over the horizontal change, or rise over run. Vertical is the amount of change up and down. Horizontal is the amount of change right or left. So if we have this graph, our vertical change is our rise, and our horizontal change is our run. And there's a tip to remember which comes first. You have to rise before you can run. So rise comes over run. So if we count this, we have a 1, well, I guess we're going by 5s. So 5, 10, 15, 20, 25, 30, 35 over our horizontal change, which is 1, 2, 3, 4, 5. So that would be 7. Sometimes the information can be presented in a table rather than in a graph. So here we have an example, number of videos and rental fee. And the formula to find the rate of change is the change in the dependent value over the change in the independent value. So first we need to identify which is the dependent value. When we look at the number of videos versus the rental fee, one of these will depend on the other, and the one that depends on the other is the rental fee. How much you have to pay depends on how many videos you rent. So we can divide in order to determine the rate of change. So we can just pick any of these points, 798 being the dependent, divided by 2, and that will give me 399. Or I can try another point, 1596 divided by 4 will also give me 399. So my rate of change is 399, and to put this into the format of a direct variation, I get y is equal to 399x. We can also determine the rate of change or slope of a line in another way, remembering that the rate of change or slope is rise over run, and then we can use the slope equation. The symbol for slope is m, because m stands for magnitude, and magnitude is the same thing as steepness or slope. And the formula is y2 minus y1 over x2 minus x1, where x1 and y1 and x2, y2 are points on the line. These subscripts, all they do is indicate we have different points. So this x is not the same as this x. So if we have a line on the graph, we can determine the slope in 2 ways. So we have method 1 and method 2. Okay, method 1 only works if we have a picture. Method 2 works with a picture or just having 2 points. So the first thing we need to do is we need to identify points on the line. Now, a point on the line occurs where you have a perfect crosshatch of the coordinate plane. So as we move along the line, we have a point here. We keep moving, and we have a point here. So here are 2 points. We have the point 0, 1, and we have the point -5, -3. Sorry, that should be a comma, not a parenthesis. That's better. So using method 1, if we have a picture available, I can count my rise and my run. So my rise will come to here, and my run will go over here. So I go 1, 2, 3, 4 spaces up, and then 1, 2, 3, 4, 5 spaces over. So my rise is 4 and my run is 5. So this will be my slope. Now using method 2 works with a picture or points. We already identified the points in the line from the picture. We can call this x1, y1, and we can call this x2, y2, or vice versa. It doesn't matter which point you call the 1s and which point you call the 2s, just so long as you have 2 1s together and 2 2s together. I can't call this x1, y2. So this one uses the formula. This will also work if you have no picture and you're just given 2 coordinates. Y2 is 1 minus y1, which was -3. X2 is 0 minus x1, which is -5. And every time I have that double negative, I make a smiley face to remind me that it's positive. So I have 1 plus 3 over 0 plus 5, which gives me 4 over 5, which is the same result I got from the picture. So either method will work. Okay, here's some more to try. We come along and we're looking for perfect points. And I have one here. And this is not a very good example. We'll just say that this one is a good point. It's not actually, but we'll just for argument's sake use that. This point is -5, 0. This point is 0, 3. From here we would go up 3 and over 1, 2, 3, 4, 5. So we could use our slope that way with the picture, or we can find 2 points. I have 0, 2 and -2, 3. And I could use my slope formula. I call this x1, y1, and x2, y2. I'm going to have 2 minus 3 over 0 minus -2. That's positive. So I have -1 over 0 plus 2. So my slope would be -1/2. Okay, we have types of slope. As we move from left to right, we read the slope. If we're going uphill from left to right, we have a positive slope. If we're going downhill as we go from left to right, we have a negative slope. If we're going completely flat as we go from left to right, our slope is 0. And that happens when our rise is 0. So we're not going up and down, but we're running sideways. Or we can have what's called an undefined slope. That's vertical, and this occurs when our run is 0, and that is because you cannot divide by 0.